I'm Roger Webb and welcome to this Vectric Aspire tutorial where we are going to take a model which is one of the free models in Vectric Aspire, and we're going to make a coat of arms and do a roughing toolpath and a finishing toolpath, and the next video will be me cutting it on my 6012 CNC router. So we'll start by getting some measurements here of our workpiece. Now in the X it's going to be let me see, 310 in the X. In the Y it is going to be 185, and it's 20 millimeters in the Z. Now I like to start at the material top of the material rather than the the bed. I just it eliminates any problems, and in my particular case too, I like to start in the middle of my piece of work. It's easier, I find, to sort of set the 0 on the piece of work. I mean, a lot of people I know set the 0 down here, sort of bottom left hand corner. I suppose it's it's personal preference. Now the material, oh, what am I doing to it? No, that's fine. I'm going to leave that as standard. Okay, you can bump this up, but it'll slow your computer down, and quite honestly the standard settings are fine. Let me see, what are we going to have this in? Plastic? No, where's the wood? Oak, light oak. I'm actually using oak, dark oak. Oh, I've laminated oak onto pine actually, and this will give a fairly good representation, I think. So we'll press OK, which takes us to the next screen. So I'm actually going to go straight into the clip art. Okay, so we've got our clip art opened up, and there is 600 to 700 different 3D models here. So I'm looking for I'm looking for a coat of arms with some flourish, and I do remember seeing one in here somewhere. So these are coats of arms, but there's a particular one that I'm looking for, so is that it? That one looks quite nice actually. I don't want it in a dish, I want it freestanding. So Aspire gives you a choice. You can either have it freestanding and sort of put it onto your material and machine away, or you can sort of have it in a dish, or you can have it, put it into your material, and it sort of leaves it machines it into your material and then leaves I suppose material unmachined. I don't see that one being practical to me, but this one I like. So bring it here, and you can see it's quite a nice coat of arms with a flourish. And I'm going to take this out. Ooh. I don't want to turn it, I want to pull it out. Not quite to the outer edge. And this one. get rid of that a second so I can see where my material is. Pull this over. Aspire is quite forgiving, actually. You can move things around, and that's okay. I like that. So let's go into the modeling, and we want to set a Z height. Now it's telling me here that it's already 12 millimeters high. Now I want to go to about 18. So let's take it up a little bit. A little bit too much. 18, 19. I know I've got 20 millimeter. A little bit more, maybe. Not too much. I'm okay with that. So I'm going to say okay. Okay, so now let's switch to the 3D. That looks I'm okay there with that. That looks fine to me. Let's have a little look. So all I'm doing is I'm just holding my left mouse down and just moving the mouse around so I can move the picture around. That looks quite nice. I'm quite happy with that. Okay, so let's go to the toolpaths. Now to get to the toolpaths, you just click on this little box up here, and this next screen will pop up. So okay, so what we're going to do is we're going to do a 3D strategy. So these are all the different 2.5D and you know, sort of V-bit carving. We want to do a mold making, no, 3D roughing. That's what we want. So we know the yes, 20 millimeter thickness. Center of the material is a 0 point. Material surface, that hasn't changed. This is all fine. Actually, we don't want a gap at. Now that would have been a gap at the bottom of the model. We don't want that. We want the gap to be at the top. Okay. So this now is set correctly. So you can, you know, I don't know why you would want a gap at the bottom. But there you go. So I want the waste, whatever waste material there is between 20 millimeters and nearly 19 millimeters. Well, you want the waste material at the top. Rapid movements above the material, 5 millimeter above the material, that's fine. Plunge rate, yeah, that's okay too. Home position 0, 0, X, Y, and 5 millimeters above the material, that's okay. No. Yes, that's what we want. And now this is a rough-in, so I think 3mm is a little bit too small. So we're going to select a tool, and I'm going to use a 13mm. And it's not actually an end mill, it's a 2-flute extended router cutter, and that's what I like to use. But I like to run it about 18. Oh, wait a minute, we haven't chose it yet. So we need to OK that. Then need to go into here and edit it. Right, 13mm. It's actually 12.75, but 13's okay. It just means it's going to leave, you know, 0.1 of a millimeter more material. That really doesn't matter. There are no particular notes about this. Depth of path 3mm. Oh, it's in oak. You know, if it was pine, I would probably take it out to 5mm, which is 1/4 of an inch, but as this is oak, it'll tend to splinter if it's too thick a cut, that is. So 3mm is fine. Step over 4, yeah, that's okay as well. I think this is left over from when I used this program last, possibly. 18,000 RPM. I find it works better because I use 60mm per second of feed rate. So if you are going to run your CNC router faster into the material, you need to raise the RPM up. Otherwise it'll just bog down and stall if you're not careful. Plunge rate 25mm. I normally go 50%. 50% of the actual feed rate. I find that works well. Tool number 1, that's okay. I don't have a tool changer, so you know, this is okay. And we're going to apply that. Machine allowance 1mm, that's fine. 3D raster. Now that's what I like to use. In other words, it's going to go back and forth like this, and it's going to go up and down as though it was a finishing cut, but it's going to be a you know, sort of a roughing cut. I find that works rather well in oak. Oh, I don't need ramp moves because I'm having this 3D raster. Home position, yes, that's okay. Vector, that's okay. Rough-in 1, that's okay, and calculate. Okay, that's calculated. We'll just run a quick simulation just to see what it's going to look like. Virtually what you see on here is what you're going to end up with on your material, and you can see that the raster movements, you know, it is a semi 3D. It's not sort of blocky and square. I actually prefer this type of roughing. Yeah, that looks fine to me. And so we'll go to, let's have a look. It looks okay. It looks all right. Yep. And we'll close that one. And then we'll go now to a 3D finishing. Boundary. And actually this is set from the last time I used this program, which was a couple of weeks ago, and it's there it is there. Yeah, it's a tapered ball mill. It's a 1mm radius, which is a 2mm ball. Okay, that, and edit. Now ooh, that's not quite right, is it? Cancel. Select. Oh, I don't know what I did there. Yep. This all looks better. Geometry. D. Shank. 6mm. Tip radius 1mm. Yep, that's correct. Except mine's very, very much longer. But this is okay. I suppose I could alter it. I don't know whether it's going to make any difference. We will alter it. Okay. There's about a 1 degree angle on mine. Step over 0.125. That's okay. I'm gonna go with the recommended step over here, 50 millimeters a second, 25. Yeah, I'm gonna go with that. Actually, we can step that up because in Mark 3 we can alter this. 30. I'm going to run that at 22,000 RPM. I've got a 2.2 kilowatt spindle, and there again, if you up the feed rate, you must up the RPM. Tool number 2. Okay. We're just going to do a standard raster, I think. Offset. No, we don't do an offset. Do a standard raster. Yep, that's correct. 3D finishing. Safe Z. 5mm. X0, Y0, 5mm above. Calculate. Now my computer is a fairly new computer. It's I think it's 2 terabyte, and it's, let me see, I think it's 8 gig RAM. So it'll do this relatively quickly. And there are literally millions of calculators, literally millions of calculations that this computer is doing now to do this. Oh. So many, it fills the picture with blue. So, let's do a very quick. And virtually what you see on here. Oh, what did I do then? Oh, no, it's okay. Virtually what you see on here is exactly what you're going to get on your machine. So all I have to do now is to save the roughing and the finishing strategy G-codes. I'll show you how to do that. Okay, so to save a file, you just go into the icon here, and we are going to output, let me see, no, this one first. Close. So you highlight which one you want to save, open the icon for a floppy disk. I don't want to output it to one file. I want to send out individual files. Now, if you've got a machine from wherever, now if it's not listed in here, like like a Haas or something like that, all machines understand general G-code. And this is the one I always save in, no matter what the machine is, and that is G-code millimeter tap. Obviously, if you was working in inches, you'd save in G-code inches tap. But all machines understand this G-code format. Okay, so we are going to output this now. Save toolpath to rough and cut 1. Give it a moment to save that. Let me highlight this one. G-code millimeters tap. 2mm ball nose. Save G-code. Oh, it's already here. Finish in. Save. Give that a couple of seconds. And now that will be ready to load into Mark III on my computer up in the workshop, and we will cut this. So thank you for joining me for this tutorial, very quick tutorial on setting up a coat of arms with a flourish in Vectric Aspire and saving the G-code. So the next video will be machining this in a piece of laminated oak and pine. So thank you very much for joining me, and it's bye for now.